Okay, so our figure is called A, B, C, D. And I'm going to put just a G and a P. So we are given that BD line segment bisects angle ABC and angle ADC. So this line segment here, BD, intersects or bisects ABC. So that would divide this angle here into even parts. And then ADC, so that would put that in congruent parts because the definition of a bisector. So we've shown two angles already, but we have to put it on the record, as they said. So we need to prove that angle BAD is congruent to angle BCD. Okay, so let's do our statements and reasons. So they give us all of our reasons on this. And we are just supposed to establish our statements. So the first thing is a given. So what are we given? Well, we're told that BD, we're only given one piece of information, so we know what to plug in here. BD bisects angle ABC and angle ADC. Okay, because of that, we've already established that angle ADB and angle CDB. So angle ADB is congruent to angle CDB because of definition of bisector. And angle ABD is congruent to angle, make sure I say this right, ABD, I did the wrong one. Okay, ABD is congruent to angle CBD because of the definition of bisector, because it bisected both angles, so it gave us two sets of congruent angles. Okay, so that's our angle and an angle that are set up. By the way, you can flip 18 and 19 as long as they're following after the bisects and it makes logical sense. It doesn't matter which angle that you say is congruent first. So, and because the reason for both of them is the same definition of a bisector. So we have two angles. Do we have any sides? Either an angle side or angle side angle. So we can show that this side in between the two angles is congruent to itself because of reflexive property, which once again they give us the reason. So we just have to look for which line segment does that pertain to. So it would go to BD is congruent to BD because of the reflexive property. So we have an angle side, or angle side angle really. So the angle side angle postulate lets us prove that triangles BAD is congruent to triangle BCD. So we can show that those triangles are congruent. But that's not what they're wanting us to prove in this one. They wanted us to say that angle BAD and angle BCD, so these angles are congruent. Well, now we can say that's true because we have proven that the triangles are congruent. And remember, all the corresponding parts are congruent to the other parts of a triangle. So corresponding parts, my letter's correct, corresponding parts of congruent triangles are congruent. So we can establish that those angles are congruent to one another because the triangles that they're a part of are congruent, and those angles actually correspond to one another. Okay, last proof for 25A. So we're given this fun little figure that crosses and produces two triangles. So DEF GH. So our given is that E is midpoint of FG. You can see all that. Okay, so E is the midpoint of FG, and that given one more piece of information, that DG line segment is not congruent, but parallel to line segment HF. Our job is to prove that GDE is congruent to angle FHE. So, I like, instead of saying all these letters and everything, to look at what I'm dealing with and go and establish some stuff, and then I know, like I said, what I'm dealing with. So, I'll write that in first. Okay, so E is the midpoint of FG. So because of that, we know a midpoint is the middle of the line, so that these lines would be congruent to one another. And we know that DG is parallel to FH. Okay, so we have two parallel lines. So we should probably be able to say something about some angles there. So what is our first thing that is given? Sorry, make sure I'm not blocking you. So for 23, we are told that E is midpoint of line segment FG. So we can say that line segment for 24, EF, is congruent to line segment EG because of definition of midpoint. Okay, next thing says that something is parallel to one another. We have some of those signs already filled in for us, and that's a given. So our given information on parallel is that line segment DG is parallel to HF, and that was given. So I'm just putting in the information that they already told us. The next thing is the reason is because of alternate interior angles. So it gives us a good hint of where do we go from here. So where are some alternate interior angles? So DGE, we could say is congruent, DGE is congruent to HFE because of alternate interior angles. So we have two parallel lines cut by a transversal, so we have alternate interior angles that are congruent. So angle DGE and angle HFE are congruent because of alternate interior angles. Well, then we were told we have some vertical angles. Which two are vertical angles? So DEG and HEF are vertical. We know that vertical angles are congruent. So DEG and angle HEF. So that goes there. So vertical angles. So we've established that a side is congruent, angles are congruent, angle. So let's see the relationship here. So that goes there. So angle, side, angle. So which they give us. We're going to have an angle, side, angle postulate. So that makes the triangles DEG and HEF. So DEG and triangle HEF congruent to one another. So that's 29. So we established that those triangles are congruent because of ASA, or angle, side, angle. But once again, they want us to prove something different. So they want us to prove that GDE and FHE, so these angles are congruent to one another. Well, now we can, because corresponding parts of congruent triangles are congruent. So we can say that GDE is congruent to angle FHE. Okay, so that's the end of 25A. And make sure to follow the email for all the directions that you'll need.